Okay, what I'm showing you is a local area network call name for a, um, a network that is on a small microcontroller, and it's connected to one of my engines. This is the designer of this. I might try to go in and change that, but in any case, what you're seeing is the very elementary controls for this engine. Now, the PC is facing in one direction and the engine is over here on my table. So I'm going to have to show you these things, and then I'll have to look at it. But what I'm going to do right now is I'm going to touch the headlight on. Oh, and I'm right-handed and my touch screen doesn't work. Okay, so there's a green light there. And I'm going to hit the headlight on button. Did you see that? Now I'm going to hit the headlight off button. Okay. And what I'm doing here is I'm using, I got a little glare, don't I? Maybe that's better. Focus. You can do it. Headlight on. I hit the button. Then the headlight is on. You see the green light? Okay. And then I hit headlight off. And the button goes off. Now, I also, if you look here, I have run backwards, run forwards. Right now I have those wired incorrectly. I need to reverse the wiring. And I also have the speed way too high. So let's bring it down to here, and let's say run forward, which is going to be run backwards. Okay? You can see it's rotating backwards. Now, I'm going to hit the stop from my PC and my mouse. Stop. Backwards. But it's really forwards. I just need to switch the wiring on the engine, and that'll fix that. Okay? I don't know how slow this will run, do you? That's not very slow. I may be able to go in and change some of these things. Ooh, look at that. Look at that. I'm using the arrow button to speed it up. That's pretty slow. I don't know how fast it is, but that's pretty fast. Okay. I believe you can run fast. That's pretty good. And I'm using the arrow buttons here to run the speed. Stop. Okay. Now, I'm going to turn the power off. This is a big deal for me, particularly because we're using all new technology. We're using all the same stuff. Like here we have our puff and chuff stuff. It'll get power in a second. I don't have it hooked in yet. But we have our puff and chuff, the smoke. We have DC fields with 3D print, right? And we have our all-wheel pickup, and this is with 6-wheel pickups, right? So we have a lot of the tech that we've been working on, except our famous motor control board that we've been working on, that you know, like here, right? It gets hot. It's in here and it gets hot. We put a fan in it. Now what we're using, and I'll show you one here, is a microcontroller. I have a light. There we go. There's a light. Okay, this is Wemos is the manufacturer. This is an ESP8266, and it's referred to as a D1 Mini. It's a development level 1, and it's miniaturized. It's very small. The normal size of that board is this big, and as you can see, this one is a lot smaller. It has a lot fewer inputs and outputs, but it works, it will do, well, you saw it, it does the function. I'm also using a slightly different motor controller board. This one is from Pololo, which concentrates mostly on radio controlled cars and things like that. So they are rugged and well made and can handle the loads easily that we're going to put on it. Okay. The one thing that's a little tweak is I have a 7805 because this guy can actually handle up to 40 volts DC. Well, this guy can't. He needs 5 volts. So this 7805 is a 3-pin transistor that you can feed in voltage and it will drive out only 5 volts. It's engineered to regulate to 5 volts, period. So it will send 5 volts to our microcontroller reliably and accurately, regardless of what's on the input. Now what's happening on this input is right now I have a huge rectifier and a huge capacitor, and it's sending DC voltage to the track right now. It's sending 22 volts of DC to the track. Okay, that's coming in here, and this 22 volts is being shared among the 3 pieces, my smoke controller, my puff and chuff controller, and the motor controller. They're all getting the same DC volts. This is regulated down to 5, and these are regulated by their mobile regulators. You saw we had a little smoke there at the end. I haven't adjusted these for a long time, so I'm not sure what they're giving out now. And I haven't run this for a while, and the soundboard's probably not even plugged in yet. So we got some things to do yet. But I'm getting this back to life after it's been sitting for 3 months. And for me, this was pretty exciting because this now is going to be packaged and sit back in here like the old motor controller. But if you looked at the motor controller, it's about as big as that. It's about as big as that whole test board. So I think what we're going to end up with is a nice, small, low heat package, and it should be pretty robust. Okay, now there's 2 parts to this neatness, and the other part is something I have never done. This I did before, and I just got it back together working, and I feel good about that. Okay, fine. The part that I haven't done before is there's a handheld controller. Instead of using your PC and your screens like we had, wherever they went, there they are. Instead of using that, you'll have a handheld controller with buttons and knobs and a tiny little LCD screen. Now Andy has his running, and I do not. So I am behind the 8 ball. But I'm going to work on that now that I know this works. And I've gone through the pinouts on how to route the wiring for the 2. I've got that figured out. I feel really comfortable with that. I have the documentation I need to do the handheld. So, yes, no, maybe. I don't know if that's it or not. No, that's not it. Anyway, it's here. I have it. And I'm going to get started on that. But I had to share with you because I think this is a big deal. Can't explain it enough, but it is a big deal. A lot of work went into this. This is 5 years in development. We're picking it up from a fellow in Sweden who built his train set for his kids. And then he just sent this design out for others to use, which is remarkable. Some guys do it, many don't. Here you'll see Olle Skold, 2017. The components. This software is provided free. Use and change and distribute as you like. And this is all the code. This is our railroad name. We changed it. But I have to go in and change the code that comes up on the screen now. Any case, oh boy, I am so thrilled. I am totally thrilled. Did I turn that power off? Yeah, I did. Okay. So we have the engine and runs, and it can go on there, and I could put it on the track. If I tape this whole thing on here, I could put it on the track, and we could see how many cars would it pull with pulse width modulation. That may be an interesting thing. It may just all break. I don't know. Anyway, I wanted to get that to you. Wanted you to see what's next now that all we have left is to wire up the fan, and that baby is going to be, I think, just fine with that big fan in there. Ooh, 30 by 30 by 7 blower fan. Oh boy. Won't need that on this guy, will we? It's going to be awesome. And he's going to have the mechanical puff and chuff, and then the 3D printed smoke. He's going to have the engineering soundboards and a pair of buckboards. And we're going to have to figure this wiring out and get it simplified down, and so I can tuck it inside something. But I'm extremely excited. I've wanted to do this. I knew we could. I had to stop. I had to finish my conventional work first and make sure it was rock solid. And now we can move on. That's my feeling. Plus, now I have this design. I can also hang that gear from this plastic piece here if the gear is missing, or if you have a smoke in a reverse in boiler chassis, that problem where there's no slot. I now can make that slot, or I will be able to. I made a slot in wood, right? All right, I make one in metal. There, right there. I'll make one in there. And then we'll be able to convert the oldest of engines, including, by the way, the American Flyer pre-war chassis, which are O-gauge. I can fit all of this onto the American Flyer O-gauge. All of it. The fields, the smoke, the control, the puff and chuff, the sound. This requires 15 volts to the track. It could be AC, but it's preferred DC. Right now I'm feeding it 22, and this guy has no problem. He can handle up to 40 volts DC. So this is a big deal for me. I'm excited. I'm going to go. I'm not sure what I'm going to do now. I'm not sure what I'm going to do. I think I'm going to take a break. It's pretty fun. All right. So I'll post this. You guys could chew on it. Tell me what you want to see next. I'll be working on stuff and let you know how it goes. Later.